So let's start with magnesium and bromine. Okay, we are going to write the formula. This is what we call a binary compound. Why is it called binary? Is it two metals? But that was a nice try. It's a metal and a non-metal. Okay, couple things. The metal is always written first, the non-metal is always written second. The cation is always written first, the anion is always written second. So this magnesium is going to be our cation. It's going to have a positive charge. It's the one that's going to be losing electrons. The bromine is going to be the negative. It's the anion. It's going to be accepting those electrons. Okay? Right now we only have two elements, magnesium and bromine. You good? Okay. So we are drawing Lewis dot diagrams for this so that you can understand what is happening. You're not always going to have to write Lewis dot diagrams, but I want you to draw the Lewis dot diagram the first couple of times so you understand what is happening. So that's what I'm going to do. Magnesium has 2 valence electrons. Bromine has 7 valence electrons. I've given up telling you where valence electrons are coming from, so hopefully you know that at this point. The magnesium wants to lose 2 electrons, so the first one's going to travel and transfer over to the bromine. And the reason I say transfer is because I have a metal and I have a non-metal, so it's an ionic compound, and ionic compounds, electrons are transferred. But now bromine is full. So we're going to need another bromine. You can't just go out there and find any other element. It has to be what you have. So the cation stays the same, the anion stays the same, and you got to make it work. So now we've got a negative electron. It's going to come over here. And now the bromines are full and the magnesium is empty. The amount of electrons that were lost, 2, are equal to the amount of electrons that are gained, 2, 1 for each magnesium. When you're done with that, then what you would do is you would write magnesium in brackets with a +2 charge and bromine in brackets with a -1 charge. And then you'd put the 8 dots around bromine because he has a full octet now. This bromine, there are 2 of them. So there's a couple ways we can illustrate this. We can either put a 2 down here to show that there are 2 bromines, or we can draw the whole thing again, boop, 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 and we can show there are 2 bromines. So this is what we're dealing with. We've got 1 magnesium with a +2 charge. We've got 2 bromines with a -1 charge. Capiche? Okay, so that's what I want you to visualize in your head. Understand that we have 1 magnesium. That magnesium has a +2 charge and 2 individual bromines, each with a -1 charge. Now let's pretend we didn't draw that. Let's say we just wanted to write the formula for magnesium bromide. Okay? So what I would do is I would look at my reference table and I'd say to myself, I know that magnesium is going to make a +2 charge. I know that because when I look at my periodic table, let's go grab a periodic table. Oh, here it is. Traveling to the periodic table. Everybody have one in front of them? Okay. Let's rotate this sucker. Magnesium has a +2. It's right there. See that +2? Okay. And bromine, which is on this side over here, has 3 charges, but we're using it as a non-metal. Non-metals gain electrons. There's only one choice where bromine is gaining electrons. That's the -1. That's the one we're going to use. It's the top one. The others where they're positives are used in covalent compounds when we're later on when we're doing redox. So let's just use the top one. And I'm going to put a -1 on. So here I am with my magnesium +2 and my bromine -1. In order to make my life easy, instead of drawing all this, I'm going to look at these numbers. That's a 2. That 2 becomes the subscript for the anion. The plus 2 is on the cation, so it becomes the subscript of the anion. Don't take the sign. The signs don't matter down here. These are positive numbers on the bottom, always, because those are telling us how many bromines I need. Anything cool up there that I'm missing? Or you're just zoning out? All right, this -1, you're going to take that 1, you're going to put it down here. This is called the Crisscross Method. You're going to take the 2, you're going to put it down here. You're going to take the 1, you're going to put it down here. Do not include the signs on the bottom, because these are quantities. Okay? And what it's telling you is you need 1 positive 2 and 2 negative 1s for this compound to exist. Got it, Will? Okay. Let's do this one. Calcium and sulfur. Calcium has what kind of charge? +2. Sulfur has -2. Okay, those are coming from right here. Calcium is a +2. It's right here. Sulfur is a -2. It's right there. So now what I'll do is I'll take these numbers, this 2, let's get a highlighter out, and I'm going to put it down here. I want to write it in red. I'm going to take this 2 and I'm going to put it down here. You see these red 2s? Those red 2s are a ratio. How many calciums I need for how many sulfurs I need. Well, if I have a ratio of 2 to 2, then it's the same as having a ratio of 1 to 1. In ionic compounds, those subscripts that you brought down have to be reduced to lowest whole numbers. So this would become CAS. Is that what you said, Noah? See? Ryan didn't believe you. He's a doubter. Go ahead, Joe. It always works. It doesn't always work in reverse. So let's say I give you M, G, and O. Okay? This is a real compound. Now, right now, the subscript for magnesium is 1 and the subscript for oxygen is 1. Well, if that's the case, and I ask you what the charge on this cation is, you might be tempted to say +1. But it's not +1. It's +2. And the reason for that is because this is a -2. And so these numbers were reduced. So it doesn't work in the reverse, but it will work in the forward all the time. Okay, does that make sense? A little bit? The best way to tell you to do this is when you're asked, let's say you're asked for the charge on this magnesium right here. You can say to yourself, all right, magnesium, it doesn't really work with magnesium, but oxygen is a -2, so if this is a 1-to-1 ratio, this has to be a +2. Here's one where, let's look at FeO. Okay? Look, this is getting a little bit ahead, but you're ready for it. Why is my pen doing funky things? FeO. Okay? I want to know what the charge of this Fe is. It's 2. Do you see how iron has 2 choices? Okay? If I had given you Fe2O3, now what's the charge on that Fe? +3. Okay? So with iron, there's a +2 and there's a +3. They're going to make different compounds depending on which iron you use. The transition metals, the ones that are in the middle here, have multiple positive oxidation numbers. And so when we go to name these things, we have to say which one we are using. I've been very, very careful for the last day and a half or 2 days to only use these guys in group 1 and group 2 and aluminum, because they only have one choice. But this is coming down the pike, where you're going to have to figure out which charge was being used to make the compound. For instance, here's another one. MnO2. Okay, so let's say I give you this compound, and I say, what is the charge, or the oxidation number, that's another way of saying charge, of that Mn? It is not +2. Okay, so now look at oxygen. Oxygen has a -2 charge, right? If oxygen has a -2 charge and I have 2 -2s, and I have one of these, what number has to go there to make it all equal to 0? +4. So in this case, MnO2, yes, the formula was Mn1O2, and the reason for that is because when I took the +4 and the O -2, and I crossed them down, 2 and 4, these two numbers got reduced to 1 and 2. You have to be able to figure out what this is going to be. Hold on one second, Abby. The easiest way I find to do that is to go, all right, well, if I have MnO2, and I know that oxygen's a -2, you see how there's only one choice there? So I'm going to make that in blue. Let's say that's -2. I'm going to make this an X. Okay? And I'm going to say to myself, self, I have 1X. 1X. And I have 2 -2s. If I have 1X and 2 -2s, and I know that the whole thing needs to add to 0, now I could just do straight algebra. Yeah, oh my goodness. Now we're getting to good stuff, guys. All right, 1X minus 4, 2 times -2 is 4, equals 0. X equals +4. Isn't that what we said it was? We're going there. But in the next couple days. We're going there. We're going there, so buckle your seatbelts, baby. All right, let's back up a little bit. You good back there? you don't sound convinced. All right, so let's back up just a little bit, and let's go back to the basics, where I'm only using group 1, group 2, so there's no question about what the oxidation numbers are, or what the charges are. Let's say I have lithium and sulfur, and I want you to write the formula for that. So what we'll do is we'll write down lithium. What's its charge? +1. There's only one choice there, so that's good news. And sulfur is -2. I'm going to cross them down. I'm going to get a 2, and I'm going to get a 1. These green ones, I have to see, can I reduce them? Nope. So my formula is going to be Li2S. Beautiful. Yeah, I'm doing the easy ones first. Okay. How about magnesium and oxygen? That's a bad G. Magnesium is a +2. Oxygen is a -2. I'm going to bring the 2's down. They're going to cancel, and I'm going to end up with MgO, magnesium and oxygen. Okay. Now let's name these. These are called binary ionic compounds. What does binary mean? Not 1, 2. Bi means 2. Okay, binary compounds have 2 elements. and only 2 elements. That's all I've given you so far. Magnesium and oxygen, lithium and sulfur, 2 elements. If you have a binary compound, and let's say our formula is MgO, this is how we name them. The first cation, cations are written first, the positive, is going to keep its name, magnesium. The anion, which is the negative ion, that's written second, is going to change the ending of its name to IDE. So instead of oxygen, we're going to say oxide. Instead of fluorine, we'd say fluoride. Instead of bromine, we'd say bromide. Instead of iodine, we'd say iodide. Instead of sulfur, we'd say sulfide. Sure. When you come back, can you bring that pass over to me so I don't have 2 of them hanging over there? CAS, what's its name? It's not Bob. Calcium sulfide. Calcium sulfide. Okay, what's the cation? The calcium. What's the anion? The sulfur. Potassium oxide. What's the cation? The potassium. What's the anion? The oxygen. Ionic compounds are always made of 2 parts. They're made of the cation and the anion. The cation and the anion. And this one is potassium oxide. What's that? Question, you good? What's MgH? That's actually MgH2. Magnesium hydride.
Wait, how do we know when to put the I and when to?
Okay, I'm going to say it again. Listen, who just asked me that? Raise your hand. Good. All right, ready, Nick? The first element keeps its name, magnesium. The second element ends in IDE. This.
How do we know when, which part of the second element to cut off?
Well, that's a good question. Do the best you can. Okay? So if you do not say hydrogenide, that sounds silly, but hydride is fine. The reason I use this one is because hydride, this is what I don't want you to say. I don't want you to say hydroxide. Because hydroxide, Lily, what happened?
That's what I said.
Okay. Hydroxide is a polyatomic ion. Oh.
Yeah,
Okay.
wait. I on a test, and I write hydronide, but it's like 2 different points. I was like,
Hydride. You can't say hydronine.
well, what if I
It has to end in IDE.
yeah, but like hydronide.
Yeah, hydronide, I'd take it. I'd take it. Okay? But you'll get used to hydride as the year goes on. You're not going to write hydrogenide. Okay? But yes, I would take it. Okay? No, yeah, probably. Going back to your polyatomic ion chart, which is table E. Okay, it's right here. Hydroxide is a polyatomic ion. Do you remember that we played Yahtzee and I said there was 6 or 7 or 8 of them that are going to come up all the time?
Are we going to play again?
Not right now. Okay? Hydroxide is a polyatomic ion. It has oxygen in it. Listen to the words I'm saying. Hydroxide. Hydride only has hydrogen. Hydroxide has hydrogen and oxygen in it.
Then why don't you keep the entire first word?
Because this is the This is the negative ion. So if you were to look at this guy, it would look something like this. Na, which is the cation, the positive ion, and OH, which is the negative ion. Okay? Remember, there's two pieces to every ionic compound. This is the cation. This is the anion. Is this a binary compound? No, thank you. It's not a binary compound because I have how many elements there? 3. Okay? We didn't do 3 yet. You guys are just jumping the gun, right? So, if you have 2 elements, you're going to take the name of the first one, and the second element gets ended in IDE. If you have 3 elements in it, you don't end it in IDE. You say the name of the first one, and then you say whatever the name of this polyatomic ion is. So this would be sodium hydroxide, because OH is a polyatomic ion and it has its own name. Uh-oh, Lily's looking at me like I'm crazy. You see it there on table E, Lily?
Yeah.
Okay, go ahead.
How do you, after the same structure?
Yep.
But how do you tell the difference between, like, either polyatomic thing or a
Binary?
yeah.
Okay, so let's say I just put an arbitrary one up here. Let's say I see CaSO4. Okay? Couple of things. First off, I want you to be able to recognize your polyatomic ions. There's one in there. But if you can't, you can say to yourself, self, there are 3 elements in here. If it's 3 elements, there's a really good chance there's going to be a polyatomic ion in there. You just got to find it. Okay? If I just wrote CaS, there's 2 elements, no polyatomic ion. Okay? One more thing before we go. When you have a ternary compound, one that has 3 elements in it, 3 or more, okay? The types of bonds that are in here are both ionic and covalent. They're ionic in the sense that the calcium is a +2 ion, and the sulfate is a -2 ion. So the polyatomic ion, this is acting like one piece, and this is acting like one piece. So the ionic bond is right here between the metal and the non-metal of these guys. What kind of bond is in here? Covalent. It's between 2 non-metals. See it? Okay. So if you have a polyatomic ion in a compound like this, you have both ionic and covalent bonds. How are we doing out there? On a scale of 1 to 10, you think you got this? We need to practice, don't we?
Yeah.
Okay. Hold on. Let me give you some practice. All right. Look at the answers for the first one. Okay. See if you got them right. Are they too small for you? How's that? Nailed it. Fire. I don't know about fire, but you're cooking. Is that what you're supposed to say? You're cooking. See, you could teach this old dog new tricks. Page looks like this. There's the top. I'll read them out loud. That would be easier for you. Just read on your paper. Potassium chloride, lithium oxide, calcium bromide, lithium hydride, magnesium bromide, potassium oxide, zinc oxide, strontium sulfide, calcium sulfide, aluminum sulfide. If you don't have them done, Don't write them in. Just check the ones you have done and then do the other ones. I'm videotaping this. This is on tape, so you can check them later. Zinc fluoride, silver nitride, sodium fluoride, barium oxide, sodium sulfide, aluminum bromide, lithium nitride, potassium fluoride, strontium iodide, magnesium oxide, aluminum oxide, and calcium hydride. How'd you do? Woo-hoo! Alright, I just want to point out one more thing before I stop this tape. I know that it's on here, but this was from my other class, so let's say you're looking at strontium sulfide, number 8. Okay? They may or may not ask you to highlight or say what the cation is. An ionic compound is always made of 2 parts. A cation, which is the positive part, and an anion, which is the negative part. The cation, in this case, is strontium. The anion is the sulfur. In the calcium sulfide, the cation is the calcium. The anion is the sulfur. Tomorrow, when we start introducing ternary compounds with the polyatomic ions, I want you to understand that it's still made of 2 parts. The positive part and the negative part. Okay? Alright, if you are done with all of this, please finish up that quizzes and that ed puzzle. And if you don't finish it in class, finish it tonight.